Hi, my name is Kevin Jones, and this is the introduction chapter to the Understanding the Java Virtual Machine Memory Management class. In this class, we can take a look at various aspects of garbage collection and memory management in the Java Virtual Machine, including how the GC works, how we can interact with the garbage collector, both from an external point of view, i.e. using some of the tools that the Java Virtual Machine provides for us, and also how we can interact with the garbage collector internally, using some of the classes within the VM. Before we do that, I think it's good to understand why we need garbage collection at all. So in languages before Java, such as C and C++, whenever we allocated memory, so in this example where we allocate an object, at some point we need to remember to delete that object and to free up that memory. If we didn't do that, we'd end up with a memory leak. In Java, that's not the case. So in Java, we can allocate an object, we can use it, and then when that object is no longer being referenced, the garbage collector will release the memory used by that object. There are also issues around who should delete an object. So here we call a method called getAccount that returns an account object. Who actually owns that object? Is it the receiver of the account object? So am I responsible for deleting it? Or is it the giver of the object, the thing that implements getAccount? If we're not clear about that, and neither side deletes the object, we end up with a memory leak. If we're not clear about that and both sides delete the object, we'll end up with some null pointer exception later down the line, which will be very, very hard to track down. Finally, we can use objects with some confidence. So long as I have a reference to an object, there's no way the garbage collector will free up that memory. I will always be able to hold on to that object and use it. In other environments, such as C++, a thread in the background may take a reference to that object and delete the object. When I then come to use it, I now have a pointer that's pointing at nothing, and end up with either memory corruption or with a null pointer exception somewhere later in the code, against something else that's very, very hard to track down. Garbage collectors make a promise, and that promise is they'll claim no live objects. However, garbage collectors make no promise about dead objects. They may collect them, they may not, and if they do collect them, you don't know when they're going to run, i.e. when that memory is going to be reclaimed. So here, for example, we allocate an account object, we do new account, and we have something that references a block of memory that contains that account object. If at some later stage we take that same variable and point it at a new account, we're now referencing a new piece of memory and a new account object. The only guarantee that we have, and it's a good guarantee, is that that second account object will be alive forever. So long as we have a reference to it, the garbage collector won't collect it. We have no guarantees about the old account object. It's no longer being referenced, and it may be reclaimed, but it may not. Even if we have an environment like Java, where the garbage collector will run, we don't know when it will run, and we don't know that it will run before the end of our application.